First Computer Systems, building and upgrading your own computer. My name is Tracy White, and this is Mike. Together, we will be illustrating and amplifying your technical starter package. This tape is divided into 3 parts. In Part 1, we will explain all the steps involved in assembling and setting up a computer. We will look at component alternatives and some example applications. In Part 2, we will discuss some essential considerations for upgrading your computer. We will explain how you can ensure your computer won't quickly become obsolete the first time a new component or enhancement is announced. In Part 3, I'll talk about testing your computer, whether you have built it from scratch or upgraded it. Since this tape doesn't permit us time to provide a complete primer on computer basics, it is necessary that we make a few assumptions from the start. Before you begin to work on your computer, you should already have an understanding of how computers function and of basic computer applications. And you should also be familiar with the computer terms and acronyms. The fact that you are watching this tape now probably means that you own or use a computer now. Your technical starter kit contains all the necessary details. However, if there is something you don't understand or you need technical support, contact First Computer Systems by calling the numbers listed at the end of the tape. If you're going to be building a computer with the aid of this tape, you should have made some essential decisions before you start. You should know generally how your new computer will be used and what type of software you will be utilizing. Will you be using your computer for home or business? Will you be using applications with a graphical user interface? Graphics-oriented applications require more memory. You should have decided on an operating system or DOS. Will you be using MS-DOS, OS/2, or Unix? Or will you use one of the Apple operating systems? Will your machine be a part of a network or will it stand alone? If in a network, will your machine be a workstation or a network server? Large spreadsheets or scientific applications may require a math coprocessor. Computer-aided design and graphics applications normally require higher resolution video displays and enhanced video cards. There are several types of system configurations to choose from. Which one you choose depends on your answers to the following questions. What type of case will best fit your needs? How much memory should your system have? Will you need a monochrome or color monitor? What video resolution will you require? How many, what size, and what type of floppy disk drives will you have? They will affect the type and size of the case you need. Will you have a hard drive? How much capacity should it have and what type of interface is best for your system? The number and types of peripherals you will use now or at a later time should be considered. Also, how expandable should your computer be to allow for future upgrades? These are all factors that you should consider before you begin to build your computer. All computers are a system of components working together. The first component is the case and power supply. Size and shape of the case are determined by where and how you'll use your computer, as well as your own personal preferences. Limited desk space will often dictate that a tower case may be preferable to a regular desktop case. The number of drives for both floppy and hard disk drives is an important factor. Many people choose to install 2 floppy drives initially, later adding a CD-ROM or a tape backup in additional vacant bays. In the rear of the case are the expansion ports that allow peripherals and upgrades to be added to your system. The expansion ports should match the number of expansion slots you will have on your motherboard. Many cases today are sold with power supplies already installed. Normally, a 200-watt power supply is adequate for a 386-25 megahertz machine or smaller. A larger, more powerful machine may require a larger power supply. This desktop case has 3 5¼ inch drive bays and 2 3½ inch drive bays, all accessible from the front. It has adequate room for floppies, a hard drive, and expansion room for an additional hard drive, tape backup, or a CD-ROM. In the back, this case has 8 expansion ports. Also, here is the keyboard socket and the power supply. This mini tower case is vertical and is used where space is limited, or in a situation where you would not want to put the monitor on top of the case. Though it is compact, it still has 8 expansion ports in the back. On the front of the case is a digital display, which shows the clock speed of the computer. Here we have 2 5¼ and 2 3½ inch floppy bays and 1 hidden bay that isn't accessible from the front of the case. If you choose a mini tower, make sure that the motherboard you install is small enough to fit in the small case. This mid-tower case comes with 200-watt power supply. This case also has a digital readout and the same number of drive bays and expansion ports as the desktop case we have just seen. The essential difference between this case and the desktop case is this one is vertical and takes less space on a desk. Often, vertical cases are kept on the floor with only the keyboard and monitor on the desk. This is a full tower case. It has 8 expansion ports in the back. Some cases may have more or less than that. This case has a 230-watt power supply, adequate to drive a 386-33 megahertz machine. It has a 5¼ inch bay accessible from the front, plus 2 hidden bays. You'll notice that this case has essentially the same switches as found on all the cases. The on-off switch, the turbo switch, which allows you to select between the highest or lowest speed of the machine. The reset switch, which allows you to do a soft reboot, as opposed to turning the computer off and back on. The keyboard lock, which allows you to lock the keyboard so no one else can use it. And, like many cases, a digital readout that shows clock speed. The second essential item you must consider is the motherboard. The physical size of the motherboard must be appropriate or it won't fit into the case you plan on using. Though there are many types of motherboards, they all have some things in common. All motherboards have central processing units or CPUs. Some CPUs are already soldered directly onto the board as you see here on this 386 SX16 motherboard. This board has 8 expansion slots, 2 8-bit and 6 16-bit. This board does not have a 32-bit slot. Some motherboards may have 3, 6, or 7 slots. All motherboards have a keyboard socket, power connectors, and memory slots. Most boards have a socket for a math coprocessor. Lastly, all motherboards have some type of basic input-output system or BIOS, which controls how data gets into and out of the computer. AMI and Award are 2 types of BIOS used on many motherboards. Here is a 386-33 motherboard with a CPU that can be changed by plugging in a new CPU. It has a math coprocessor socket and cache memory which speeds the processing. The memory sockets are located here on this board. This particular board has 7 16-bit expansion slots and 1 32-bit slot which can be used for a memory card. You may recall that the 386 SX16 board we just saw didn't have a 32-bit slot. Just as all computers need a CPU, they also need a random access memory or RAM. There are basically 3 types of memory chips. All memory chips come in a variety of configurations. Check your user manual for your motherboard to decide what chip you need. SIPs look like this. with pins extending downward. This is a 1 meg by 9 SIP. Another type of memory chip is called SIM. This is a 1 by 9 SIM. Both SIPs and SIMs are also available in a 256 by 9 and 4 by 9 variety. The third type of memory chip is called dynamic RAM or DRAM. They come in a variety of sizes also. Many computers today come packaged with either 1 meg or 4 megs of RAM as standard. With all computers, there's a need to store large amounts of data. The most common device used is the hard disk drive. Hard disk drives come in a whole range of capacities, such as 20 meg, 40 meg, 100 meg, and so on. Hard drives come in a range of interfaces. They are IDE, RLL, MFM, SCSI, and ESDI. This 40 meg hard drive is designed to be mounted in a 3.5-inch bay. This drive has an IDE interface. It must be used with a controller with a matching interface socketed to the motherboard. In this case, an IDE controller. Controllers come in the same 5 types of interfaces as hard drives: IDE, RLL, MFM, SCSI, and ESDI. This 16-bit controller matches our IDE hard drive. It is faster than an 8-bit controller. Here is where the controller plugs into a 16-bit expansion slot. This controller has cables to connect 2 floppy drives and 2 hard drives. Some controllers, such as this one, have built-in input-output ports. This one has 2 serial, 1 parallel, and 1 gain port attached. This other IDE 16-bit controller does not have a built-in I/O. If you used this controller, you would also need a separate I/O card that would allow you to communicate to devices like a printer, a mouse, or an external modem. This controller has connections only for the floppy and hard disk drives. This is a separate I/O card. Most I/O cards are 8-bit types. This card comes with 1 serial and 1 parallel port. It also has jumper connections which allow it to be connected to the additional ports. Since most software comes in floppy diskettes, it is necessary to have at least 1 floppy disk drive on your computer. There are 2 sizes of floppy drives. Each comes in a low and high density type. The 3.5-inch low-density floppy holds 720K, and the high-density version 1.44 megabytes. The 5.25-inch floppy is formatted for either 360K or the high-density 1.2 megabytes. Most controllers allow you to control 2 hard drives and 2 floppies. If you need more than 2 floppy drives, it is necessary to have a controller that is designed for more than 2 floppies. There are many different styles of keyboards. 84, 101, 102 are examples. This is a 101 keyboard. One item most keyboards have in common is a switch on the bottom, which allows the keyboard to be used with either an XT or an AT type computer. The older XT type of computer is slower and uses only 8-bit slots, while the AT is faster and uses both 8 and 16-bit slots. It is important to make sure your keyboard is set for the type of computer you are using. In order for you to see the output of your computer, you will need a video display or monitor. There's a large assortment of monitors from which to choose. Your choice will depend on your personal preference and how you use your computer. Monitors range in size from a compact 9-inch monitor up to 20 inches or larger. Most monitors used today average between 13 and 16 inches. Monitors come in monochrome and color varieties and span a broad range of image resolutions. CGA monitors are at the low end of the resolution scale. Next come EGA, VGA, and Super VGA, in that order. Each resolution also supports applications in lower resolutions. Resolution is measured horizontally in dots and vertically in lines. A VGA monitor normally delivers 640 by 480 or 800 by 600 resolution. A Super VGA monitor with 1 meg of RAM is capable of delivering up to 1024 dots horizontal by 768 lines vertical resolution. The size or pitch of a dot can significantly enhance the image on a monitor screen. A fine pitch monitor, for example, has 0.28 millimeter dots or smaller. In order for your monitor to function with your computer, you need a matching video card. If you have a Super VGA monitor, you need a Super VGA card. This is a 16-bit Super VGA card with 1 meg of memory. It has a resolution of 1024 by 768. The amount of memory on a video card will also affect the speed of your video display. The speed of your monitor becomes significant when you are using powerful graphics-based applications. Most video cards have between 256K and 1 meg of memory. If you have a monochrome monitor, you may only need a monochrome card. This is an 8-bit monochrome card with 1 parallel port and 1 port for the monitor. Most monochrome cards are Hercules compatible in terms of graphics. All video cards should come with software drivers that enable you to utilize the card's graphics with your applications such as computer-aided design, desktop publishing, or Windows-compatible applications. When you purchase a video card, check to ensure that it comes with a set of drivers for your applications. Once you have assembled your computer, you cannot run it without an operating system. MS-DOS, OS/2, and Unix are all examples of major operating systems. Each system is available in different versions. The latest version may not necessarily be the best version for your needs. Also, all operating systems require compatible hardware. An Apple operating system, for example, must be run on Apple-compatible hardware. Lastly, you need to run some type of testing software to thoroughly check all the components of your system and diagnose any problems that need to be corrected. Check-It and Q&A Plus are all popular examples of testing applications. This system will have a 1.2 meg and a 1.44 meg floppy drive. We will install a 40 meg hard drive with an IDE interface and a matching IDE controller card with 2 serial ports, a parallel port, and a gain port. We will use a Super VGA monitor with a 16-bit Super VGA card that has 1 meg of memory. The keyboard will be a 101 type switched to the AT mode. We are going to build this system into a desktop case that comes with a 200-watt power supply and speaker already installed. Lastly, we will install version 5 of MS-DOS as our operating system. Before beginning, however, there are a few points that we must cover. Do not attempt to connect your system to an electrical power source until assembling is complete. Do not open or dismantle the power supply. Make sure that you are grounded while assembling your computer. The only tool you'll need is a Phillips head screwdriver. However, a small computer toolkit can come in handy, especially when you need a pickup tool to retrieve a screw that has dropped into a tight spot on the motherboard. All necessary hardware comes packaged with the case. Necessary documentation comes with each manufacturer's component and is also provided in your technical starter kit. Your work area should be clean and should provide enough space for you to organize your components and hardware. At this time, we will begin assembling our computer. First, remove the case cover by removing the screws securing it to the base. Set the cover aside for now. Inside the case is the power cord and the hardware kit. Remove them and set them aside. Locate the 4 legs provided in the kit and install them on the bottom of the case. To make it easier to install the 5 1/4 inch drive, remove the 3 1/2 inch drive bracket and set it aside. Move the power cables away from the drive bays. Pop out the drive bay cover by pushing with your fingers from the inside. Place the 5 1/4 inch floppy drive into the bay and align its faceplate with the front of the case. Secure the drive to the drive bracket with the screws provided in your hardware kit. There are provisions for 4 screws on each side. It is necessary to install at least 2 per side. Be careful. Do not tighten the screws too tightly or they will extend too far and interfere with the performance of the floppy drive. Next, we will install the motherboard. From your hardware kit, remove the white plastic insulators and at least 2 brass mounting nuts. Notice that the case has generic holes for mounting different types of motherboards. The motherboard has holes for receiving the plastic insulators, which in turn lock into the holes in the case. First, align the motherboard with the holes in the case to determine which holes will align properly. Remember to orient the board so that the expansion slots are closest to the rear of the case and the keyboard socket is aligned with the appropriate opening in the case. Then snap the white plastic insulator into the preformed holes in the motherboard. As a minimum, each corner should be supported with an insulator. Now screw at least 2 brass mounting nuts into the case in positions that will align with the holes in the motherboard. With the insulator installed, carefully slide the motherboard so that each insulator locks into a corresponding hole in the case. Secure the motherboard into the case by installing 2 screws and insulating washers through holes in the motherboard into the brass mounting nuts that you have previously installed. Check your work in 2 ways. Make sure the motherboard is stable and cannot be shifted. Then, plug the keyboard into the keyboard socket to make sure the motherboard is aligned properly with the case. If everything checks, remove the keyboard. If not, realign and resecure the motherboard. The next step is to attach the power cables to the motherboard. Locate the 2 power cables labeled P8 and P9 coming from the power supply. Place them side by side so that the black wire on each cable is on the inside, adjacent to each other. Place both cables in the matching receptacles on the motherboard. The 3 1/2 inch floppy drive can now be installed without interfering with the motherboard. We could choose to mount the 3 1/2 inch drive under the 5 1/4 inch drive. To do that, we would have to use the 5 1/4 inch drive bay adapter and adapter faceplate supplied with the drive. But if we did that, we would occupy a bay that we might want to use for later upgrade. So, I have chosen to mount this floppy drive in one of the bays for a 3 1/2 inch floppy. Just like before, pop out the bay cover. Now mount the drive into the 3 1/2 inch drive bay bracket that you removed earlier. Check to make sure the drive will be right side up. Do not completely tighten the screws. The drive should slide back and forth in the bracket. Place the bracket in place and align the front of the floppy drive flush with the front of the case. Holding the drive in that position, go ahead and tighten the screws that hold the drive to the bracket. Again, do not over-tighten the screws or they may protrude into the drive itself and cause it to malfunction. While the bracket is detached from the case, it is best to go ahead and install the hard drive. With the power connection facing the rear of the bracket, align the front of the hard drive with the front of the bracket and secure it with screws. Make sure you do not over-tighten the screws or they may extend into the hard drive case, causing it to malfunction. Tighten them just enough so that the hard drive does not move in the bracket. Lastly, attach the bracket back in the case with the screws you originally removed. When you look at the connectors on the remaining power cables, you will see one cable with a connector smaller than the rest. Plug that one into the 3.5-inch floppy drive. Connect two other power cables to the hard drive and the remaining floppy drive. All the connectors are designed to fasten only one way. The extra power cable can be used in the future for an extra hard drive or a tape backup. If more than one additional power cable is required, an extension can be used. Now that all the drives are installed, it is necessary to install a controller that will allow them to communicate with the motherboard. Since the hard drive we installed has an IDE interface, it is necessary to add a controller that has a matching IDE interface. As stated earlier, IDE controller cards come with and without built-in I/O. Since using a separate I/O card would occupy one of the expansion slots, we will use a controller with built-in I/O. Though it doesn't matter which 16-bit slot is used, we will use a slot near the drives to facilitate cable connections. Make sure the card is seated well into the expansion slots. Notice that there are two types of cables supplied with the controller, one for the hard drive and a different type for both floppies. The connecting pins on the card are labeled HD and FD for the hard and floppy drives respectively. Both cables have a red line running along the entire length of the edge. When plugging the cables to the card, make sure the edge of the cable with the red line is on the left or toward the front of both cables. Connect the hard drive cable to the hard drive. Attach the end of the floppy drive cable to the 5.25-inch drive that will be drive A. Plug one of the remaining connectors on the same cable that fits best into the 3.5-inch floppy drive or drive B. Secure the card to the case with a screw. This gives us one parallel and one gain port. Now we will add two serial ports to our system. There are already pin connectors on the controller card for that purpose. The supplied cables end in one 9-pin and one 24-pin serial port. It is not important to which pins the cables are connected, as long as both cables are parallel with no twist. Using brass mounting nuts, attach the ports to the case in the cutouts provided. The last card we will install is the video card. In this case, it is a 16-bit Super VGA card. It can be socketed in one of many of the 16-bit expansion slots. This still leaves 6 expansion slots for future upgrades, such as an internal modem or a fax card. Secure the card to the case with a screw. With any card with a port attached, such as this, it is important to fasten it to the case in such a manner that the port will be centered in the opening in the case. If the ports are not centered, it may be difficult to properly plug a connector into the port. At this time, we will close all empty openings in the case with the covers provided. This will keep out dust and foreign objects. Though not absolutely necessary, it is advisable to label the ports. Now we will be installing memory onto the motherboard. We will be installing 4 megabytes of RAM. Since the memory requirements vary for each type of motherboard, it is necessary that you check your documentation. The cable connections. Front of the case can now be connected to the motherboard. The location of each connection is marked on the motherboard and in the documentation. It is also an easy matter to identify each cable by tracing each one back to its separate switch or light. The cable from the hard drive light is an exception. It must be attached to the controller card instead of to the motherboard. The pins for that connection can be found at the top of the card next to the drive cable connections. Connect the turbo switch and light, the keyboard lock, and any other cables that apply to your system. The speaker is also connected to the motherboard at this time. In this instance, the speaker is already installed in the case. If your speaker is not installed, secure it to the case with the hardware provided. When all necessary cables are connected, it is best to tie them together and fold them neatly. Lastly, ground your system by attaching the ground wire to the case. The battery for the internal clock for this motherboard comes installed and is rechargeable. If your battery is different, connect it to the motherboard and secure it in place. The case cover should now be replaced and secured with screws. After your computer is assembled, it must be set up before it can be put into operation. Connect the keyboard and monitor to their appropriate ports before connecting the power cord to an electrical outlet. Some monitors have a power cord of their own. Make sure you use an appropriate surge protector to protect your investment. To begin the setup process, turn on your computer. The system counts the memory and reports that it detects 4 megs of RAM. During the memory check, you will see a message that instructs you to press the F1 or delete key if you want to run the setup program. Press F1 or delete and run the system configuration setup. A menu will appear with a choice of setups. Select the standard setup, which is the CMOS setup. The next screen provides setup options. Use the direction keys to scroll through the option and set the correct date and time. If you have installed a hard drive, you must specify the number of cylinders, heads, and sectors for that drive. To get that information, all you need to know is the brand, size, and type of hard drive you are installing. We will provide you with a listing of the most common types of hard drives. That listing will provide the necessary information for each type. The Technical Starter Kit manual also lists types of hard drives. If your type is not listed and the documentation that came with the hard drive does not contain the information, you may obtain it from the dealer where you purchased the hard drive. In this case, we are installing a 40 meg Seagate hard drive. Our list indicates that it is a Type 42. When we entered Type 42, we saw that the drive is supposed to have 981 cylinders. However, we know from the documentation that came with our hard drive that the drive actually has 820 cylinders. Therefore, we will enter a Type 47, which allows us to define our own type of drive. The Seagate documentation tells us there are 6 heads and 17 sectors. When we enter that information, the field labeled size automatically displays a 41 meg drive, which is correct. So, Drive C is now installed. If we had a second hard drive, we would install it as Drive D. This setup program only detects the 1.2 meg floppy that we installed in Drive A. It is necessary to tell the system that we also have a 1.44 meg floppy in Drive B. The system has already detected our VGA display and the keyboard. Don't worry if you don't see Super VGA. This setup program does not differentiate between the two. Follow the on-screen instructions to return to the main menu and save the setup by selecting Write to CMOS and exit. Reboot the computer again by pressing the Reset button. Now, the system configuration window should match your setup. However, the system will not boot without a bootable disk. Place a DOS bootable disk in Drive A and reboot. Make sure the DOS disk is the same version as the operating system you intend to use on your system. Press F3 and follow the on-screen instructions to exit and to arrive at the DOS prompt. It is necessary to run 2 files to prepare the hard disk to accept data. At the prompt, type dir and press Enter to see all the files in Drive A. We will run the fdisk command to partition the hard drive and the format command to format it. Type fdisk at the prompt and press Enter. Enter 1 to create a DOS partition. Select 1 again to create only one primary partition. Enter Y for yes to use the maximum available space. Details about the fdisk command can be found in your DOS documentation. You may add a label if you like, or just press Enter to reboot the system. In this case, we're going to format the hard drive using MS-DOS version 5. At the prompt, we type format C:/S and press Enter. Since there is no information on the hard drive to lose, we will type Y for yes. The hard drive is now formatted and the file command.com is copied so that our system will boot to drive C. When the format is complete, you may enter a label if you wish. We will just press enter for none. Now, change drives by typing C: at the prompt. At the C prompt, type dir to see the directory of drive C. This screen displays the current drive information. Here we see that there is only one file listed and that there is approximately 42 megabytes free on the hard drive. If everything has been done correctly, we should be able to boot directly to drive C. Remove any disk from the floppy drives and reboot your computer. It should now reboot directly to drive C. When the system boots, you will receive a message asking for a new time. If the time is not correct, change it. Otherwise, your system is complete. Now you should check the operation of your system before installing any applications. Check the operation of the controls on the front of the case to make sure their connections are working. The power light should be on when the system is switched on. The turbo light should be on when the turbo is engaged. The reset button should reboot the machine. When the lock is engaged, the keyboard should not be able to input to the computer. On this particular machine, the fastest speed of the system is 33 megahertz with the turbo switched on and 8 megahertz with the turbo off. Your machine is now ready for testing. Now you have a complete working computer, and it should serve you well. However, over time, your needs may change, and technology will offer enhancements and options you may wish to add. Before you decide to upgrade, however, you should first determine if your system can be easily upgraded. Is your case large enough to add additional components? Do you have enough expansion slots of the right type? Will you need a larger power supply or new cables? Will the upgrade be compatible with your existing components or software? You may choose to pay to have your system upgraded, or you may choose to do it yourself. Not only will you save money, but you'll have the satisfaction of knowing you did it yourself, just the way you wanted it done. Once you have decided to upgrade, you should choose components that do not limit or restrict future upgrades. Shop around. Usually, the best values are found through reputable mail-order distributors. Also, make sure you have all the information you will need. There are books, manuals, and videotapes that can provide valuable assistance. Of course, don't forget appropriate test software to diagnose or fix any problems you may encounter. Lastly, before you make any changes to your existing system, make yourself a written backup of your dip switch and jumper settings. There are 6 major areas upgraded by users: floppy drives, hard drives, memory, video displays, math coprocessors, and motherboards. If you need to add a floppy disk drive, make sure you have a vacant drive bay in your case. Is the bay the correct size, or will you need to use an adapter? Check your controller card to make sure it can accept an additional floppy drive. Also, check your cable from the controller. Is it sufficient for an extra drive, or do you need a new cable? Speaking of cables, Is there another available power cable for your new drive? Will you need an extension to supply power to the drive? The same consideration that apply to floppy drives also apply to adding or upgrading a hard drive. There are different sizes and types of hard drives from which to choose. Do you have the space to add a hard drive? Since hard drives come with different interfaces, it is most practical to add a hard drive that has the same interface as your existing controller. Otherwise, you may need to buy a new controller card as well. When you purchase a hard drive, you have some choice of speeds. Make sure your new drive's speed is adequate for your needs. If more RAM is needed, make sure you check your motherboard manual to determine what type of memory chips you need. Does your system require SIMs or SIPs? Does your existing motherboard have enough available slots for your required memory upgrade? You will probably have several options concerning chip configurations that will work in your computer. Compare configurations for economy and space requirements. If your system is sluggish, it may be due to a slow or inadequate display device for your applications. Selecting the proper display with the proper graphics adapter is the solution. You have several options from which to choose. For example, to achieve 1024 by 768 resolution, you will need a Super VGA monitor and a matching Super VGA card with 1 meg of RAM. Check your technical manual to determine your best option. When you are ready to install a math coprocessor chip, pay particular attention to the configuration of the socket and the chip. Notice that one corner of each is shaped differently from the others. When you plug the chip into the socket, make sure the odd-shaped corner of the chip is aligned with the odd-shaped corner of the socket. Press the chip securely into the socket. Make sure you do not bend any of the delicate pins on the edge of the chip. If you change motherboards to improve your system, we strongly recommend your new one be a modular type board. First Computer Systems, for example, offers this motherboard with 2 different CPU sockets. On this motherboard, there is a socket for 386 CPUs that will allow you to upgrade from a 386 25 megahertz machine to a 386 33 or 40 machine simply by changing CPUs. And should you wish to move up to a 486 33 or even a 486 50 megahertz machine, you may do so just by installing a 486 CPU in this 486 socket. This same motherboard also has a socket for a math coprocessor. The last thing you should do before loading programs and using your system is to test the system with appropriate software. There are several brands of software such as Check-It or Q&A Plus that will do the job. Your dealer will be able to advise you as to which one is best for you. In our case, we are running Check-It to test our system. Run the test software for the recommended period of time so that every component of your system is thoroughly tested or burned in. This way, you will be able to detect and diagnose any component that is defective or not installed correctly. Once your testing is complete, you will be able to use your system as a tool to make your job easier and more effective. Much has changed since the early 80s when the computer buyer sought only name-brand computers. Today, 1 in every 5 households owns a personal computer. The consumer has become computer literate and much more informed. They have discovered that there are many options when it comes to buying or upgrading a computer. This new consumer confidence has led many to begin building or upgrading their own to meet their own requirements. The purpose of this tape has been to provide you with the information you need to build or upgrade your own computer in an efficient and economical manner. If you need either technical or sales assistance, you may contact First Computer Systems at these numbers. When you call our tech support line, you will need to give our technician your access number that came with your technical starter kit. Good luck working on your own computer. And thank you for choosing First Computer Systems.